Uh, Good afternoon, all students, and I hope you are all doing very well. As a part of the project, as a part of the assessment tools that we have in engineering statistics, we have to prepare or to solve the assignments that have been assigned to you by using Minitab software. And I think I sent you the software and it's working, and we have within this course we are week by week trained on how to use that, and this video is just to remind, or let me say just to review and to remember how to use some of these ones using the Minitab. So the mission is to how to use Minitab for solving the assignments. I will take different questions from different assignments, and I will try to use some small parts which is I have been received many questions regarding the assignments, how to use the Minitab, especially when we have a group data. Now let me start with this problem. So the problem is, it was one of my assessment tools, and one of the questions from the assignments. It asks us to find how much is the number of the highway miles per gallon for 10 worst vehicle is shown here. So what is required? The required is to find the mean and the median, mean and the median and the mode and the mid-range and the range and the variance and the standard deviation for these data. So this is a kind of non-group data, or it can be said it's a raw data. In this kind of data, we have we can use the data in a very simple way. First, we have to open the Minitab, and here's the Minitab. I'm using version 16. It doesn't matter if you have any new version. So what should I do for this kind of raw data? Be aware that we are going just to enter the data in a specific column. So let me say I will start entering the data that I have, the raw data, in this column, which is column C1, and here's the let me see, yeah, this is so it's 12, 15, 13, 12, 15, 13, 12, 15, 12, 13, 15. Then we have 12, 15, 13, 14, 15, 12, 15, 13, again I have 12, 15, 13, 14, 15, 16, 14, 15, 16, 14, 15, 16, and 14, 15, 16, 17, 16, 17, 18, 17, 16, 17, 18. So we have 10 numbers. Here are the 10 numbers that we have. So to find the required mean, modes, and basically these are called descriptions or statistical descriptions. Okay, there is a central tendency measurement, which is the mean, median, mode, and there is standard deviation, and there is the other, which is this the data description. So what should we do? And this is, we have an easy way, is just to go to the mini tab, and in mini tab we are going to data, and we are going to use the, here's the data. I will go just to the I will go to the statistics, and I'll go to the basic description. So let me just make it easier. Where I should go, I will go to the data. Here's the data statistics, and I will go to the descriptive statistics, and I want to see the display descriptive statistics, means what should I know about the data. And here's what I have entered the data in column, which is here, it's called column C1, and I will select that column. This is the variable that I'm going to define, and the statistics that I'm going to find them is the mean and some square of the mean, standard deviation, so variance, and we have, I can find the coefficient of variance, and I can find the range, and also I can find the skewness and every part of the mode. Here's all the parts that it was required from me to find them. So I will go and just say OK, and if in case that you need any graphs, you can say please draw a histogram for the data, for my data, and we can do any other one, plot box, if I want to draw the plot box. That's all what I have. And then after that I will say OK. So you have to wait a little bit, and then you will see the results. So here's the data. Here's the toolbox box plot for C1, which is the data I have. As you know, here's the minimum, and here's the maximum, and here's the Q1 and median Q2, and you can just click on that one, and you can say I can say add, which means I want to see how I add what, add the data, grid lines, X and Y, and this is the all what I want to see. Okay, you can see the change here, and also I can just go and I will say add whatever I will find the data that I have in the y-axis labels, and that this will be the data here. Okay, and then I can say add, and I can see what data you need to display. I want to see the median and the mean, and that's all. Yeah, these are the data, and you can just go to the data and you can see here's the mean and the median, and basically here's the, I can say okay. I can say okay, add this. By the way, when I want to see I want to add I want to say select the item, and I want to say, yeah, here's the outlier data labels. You can say here's the outlier labels. Okay, finally I want to save. Yes, I will do the save, and I be careful that you have to save all the data together in a specific order. For example, in my case, I will just go to the any drive, and I will just open a folder. Here's the folder. I will say, let's say assignment number 1, and then in assignment number 1 I will say, yeah, save here. So this is the box plot in that one, then save. And by the way, this, and then you can just close that one. Yes, yeah, I just say save that one. Now what else I have to save? I have to save this data. So be aware that you have, when you want to just save, you have to save all the project together. Save the project, and this project you should be saved. Let me say this is project 1, and I will say this is for assignment 1, and save it in the same folder. Which folder I want to save? I say I want to save in that folder. Then it's okay, and then the Excel file will be saved here. Now what about if I have not data like this? I have, for example, yeah, close that one. If I have, this is regarding the question 1. So yeah, there is another thing that we say that we have another type of data, which is can be said we have group data, or let me say classified data. For the classified data, we know that we have classes, the classes that I have here, and the frequency, and how much is the frequency of these classes. So basically this is the classes, and this is the class boundaries, class upper bound, and this is lower boundary, and this is upper boundary, and this is their frequencies. So you may ask, how can I enter this? Or most of the questions was how can I use the same procedure but for the group data, not for the raw data? And in group data we cannot use directly statistics description for the group data. So what should we do? We should find the mean, model, and variance, and so like what we have in the calculation. In the calculation that we have, we say that the mean or the average is equal to summation n times summation fi xi square minus summation of xi fi together square divided by n times n minus 1, where n is equal to summation of fi. This is the rule, and that's here for the group data, and here's the rule. You can check that one again. Here's the rule. So this is was for by the way, this is for the standard deviation. What about the mean? The mean we have, this is the mean. So in the mean, when we need to find the mean, what should we do? We should find, for the mean, which is the mean is equal to summation xi fi divided by summation fi. So here's the mean, and here's the variance. Sorry, this is not the, this is the variance. This is the variance, and we have to take this one together underscore. So the variance is equal to again the mean for the group data. So the mean, which is the mu, is equal to x bar for the group data, is equal to summation xi fi divided by summation fi, and the summation fi usually be, summation fi is the summation of all these data, which is equal to n. Then what about the variance? The variance is equal to n times summation of fi xi square minus summation of fi xi all together square divided by n times n minus 1, and again n is what? N is the summation of fi. This is the variance, and the standard deviation is equal to the square root of this variance, otherwise it's equal to n times summation of fi xi square minus summation fi xi all together square divided by n minus 1. And this is here what we have it in the equation. Here's the equation. You can check that one. Here's the standard deviation, xi and phi and xi squared, and this will be the variance. So what should we do? We should apply this one. First of all, we have to find numerically, this is the classes, and so we have from 0 to 2 the class, and here's the frequency, which is 1. 3 to 5, which is 3. So what should I do? First of all, I have to find the xi, and you know the xi is the mid class, which means the mid of this class, which is equal to 0 plus 2 over 2, which is equal to 1. So 1 is the midpoint of this class, and the other midpoint is equal to 3 plus 5 over 2, which is equal to 4, and so on. So I have to find this one. Then after that, I will find an xi times fi, which is equal to this column times this column, which is equal to 1 times 1, which is equal to 1, which is equal to 3 times 4, which is equal to 12, and so on. And also I have to find xi squared times fi, which means I have to square that one times the fi, which is equal to 1, which is equal to 1. Squaring that, which is equal to 4 squared times the fi, which is equal to 3. That's equal to 16 times 3, which is 48, and so on. Now what else I need? I need to find the summation of fi and the summation. So what should I do? I should find these data. This is manually. Now how the Minitab can do that for me? You have first of all to enter these data. So we have from 0 to 3 to 5 in each column. So let me say this is for was for question 1. Okay, now I have question 2. Let me say this is, I will go answer in question 2. So for question 2, we have the same. First of all, let me, this question 2 will be start, or let me say, I will start here. And this will be the lower boundary. Sorry. This will be the lower boundary, and this is called the upper boundary, and this will be frequency fi. So we have from first class we have 0, the second one is 2, and the frequency is 1. This is what we have it in the So we have 0 2, we have 3 to 5, 1 3 5 2 1, 1 3 5 2 1, 1 3 5 2 1. Okay, here's we have 3 2 5, we have 6 to 8, you have 9 to 11, and the last thing we have 12, and we have 14. So that's what I have. Let me check. Let me check this one. 0 to 3 to 5, 6 to 8, 9 to 11, 12 to 14. 6, 0 to 3 to 5, 6 to 8, 9 to 11, 12, and this is the frequency. So what I will do, first of all, I have to find the xi. How to find the xi? I will name this column as an xi. This is xi. Now I will go, here's the very important point. I will go to the function. Assign function to this column. The function or for this column is this column, which is column 7, the xi will be equal to the average or the midpoint of lower boundary to the upper boundary. It means that I have to go and I will say, let me bring the magnifier. Okay, I will go with the Minitab. So I will go to this function. I will say okay. This column, which is column 7, is equal to upper plus lower divided by 2. Or I will say okay, this will be 0.5 times, open a bracket, this is the bracket, a 0.5 of what? Of the upper boundary, which is the column C. Let's select this one, lower boundary, plus upper boundary, and this will be the, so you can see, yes, here's the xi, which is equal to 0 plus 2, which is equal to 1. 3 plus 5 is equal to 8 divided by 2, 4. So that's the midpoint. Now again, we have to assign xi fi. Where is the xi fi? I will say this column is equal to xi times fi, which means which column by which column, which is equal to the column C5 times column C7. So I will go to the first cell in this column and I will assign a formula for that one. Now I'm going to find the xi divided multiplied by fi. So I will take this formula to xi times fi. That's it. So you can see, yes, we have xi fi. Now again, what we need else, I will need to have xi squared multiply fi. So I will have to find xi square times fi. So what that means, this column is equal to the xi column 7 squared times fi. So also I will go to the assign. I will say this column is equal to xi, but squaring that xi means xi multiply xi, or you can do square. This is xi square times fi. So it means that this column is equal to xi squared times fi, and you can see, yeah, this is xi squared. The second xi is 4, squaring 4, 16 times fi, 14 times 3, which is 48, and so on. Now what else that I need? That's it, because you can remember, we can go back to the formula. The formula is here. It's equal to, we need fi xi square, yes, that we had fi xi square, yeah. So we need to have a sum. So first of all, I go back to the Minitab, yeah. So when I want to, let's say, I will say this is the mean of this data. What will be the mean? The mean is equal to summation fi xi divided by summation fi. I will say the formula or the function of this column is to be a summation of xi fi, and this is very important. First of all, you have to go to the command of summation. Yeah, here's the sum. S. Yeah, the sum. I will select this one. Sum of what? Sum of xi fi. So I will say sum of column, which is xi fi, sum of column xi fi, and then the sum of xi fi divided by summation of what? Fi along. This is summation of fi Okay, so the mean is equal to the summation of xi fi divided by summation fi. So this is will be the mean. So the mean of this group data is equal to 6.7. What will be the variance or the standard deviation? Let me say the variance. Now back to this variance. Well, how should we do? We have to go to the summation of the function. Variance is equal to, as we know, then to find the variance we should first of all check the equation. As we said, here's the equation. We have summation of fi xi squared, summation n, which is the summation of fi itself, minus summation xi fi all squared divided by this number. Now how to apply this one? I will go to the mini tab and I will say that this variance, also this function, is equal. First of all, I will say open a bracket. The n, which is the summation fy, I have to go. Let me open the magnifier. So I should go here. I will say n, which is the summation. I have to find the function here, which is the sum. Here's the sum. Sum of fy, that means this will be n. Times, and be careful that use these bottoms, not other one. Then summation of fi, which is here n. That's the n, times summation of fi xi squared, summation of fi xi squared. So I have to say times summation of xi, but which one? Summation, here's the summation of xi xi squared fi, here's the. Then after that I had to say that you have to go after that, and I will say minus. You have to use this minus. And we have also open the bracket, summation, here's summation of xi fi, here's summation of xi fi, times again summation of xi fi. It means that this is xi fi squared. So summation fi, which is n, multiplied by summation of xi squared fi, minus summation of xi squared, summation of this will be okay. Now I have to go here to delete this bracket. Then after that I have to go divided by open brackets n, which is also summation of fy, here's summation of fi, and then times what? Summation of fi, but minus 1. Yeah, minus 1. I think everything went smoothly, so we can check. Okay. Oh, I have a bracket, extra bracket here. So this is the fi, this is sum minus summation. Okay, so that's probably, this is for that, this is for that, this is for this. All divided by, yeah, we don't need these ones, these two ones. So I think this is no need to have this one, and this is also no need for having this one. Yeah. Yeah. So the variance is, let me check the equation. Here's the equation. Summation fi times summation xi fi squared, that's good. summation xi fi times summation xi fi. Here it means that I am squaring that summation xi fi divided by summation fi divided by summation fi minus 1 underscore. So the variance is this one. Now what we need, the standard deviation, and basically the standard deviation is equal to the square root of the variance. So I will go also with this one. I will say it's equal to the squaring the root. You can find the command of the squaring, or can find this one, arithmetic, yeah, square root. Here's square root of what? Column of the variance. So the square root of the variance, it will give you. So this is the standard deviation of that. Now what will be else? I should find the mode, and mode is exactly what you have, the highest value. This is will be the mode. So the mode is the highest frequency. That's it, all what we have. The other question that we have, and I want to find it when you are using the Minitab, is for this question. So you can see here in this question we have an employer find yeah, we have this one. Sorry, I have to close this one. Yeah, we have an employer finds that among employees categorized as engineer in the same time the time in years of formal education received by these employees is normal distributed with a mean of 14 years and a standard deviation of 2.7. So in this question we have the mean, which is equal to 14 years, and we have standard deviation for this is equal to 0.75 years. So what is the required for a person randomly selected from the group? Find the probability that he or she has at least 13.01. I mean by this 13. That's what I mean. And by the way, this is your n, so you don't need to add anything here. Yeah. Yeah, so we have at least 13 years of what of find it. So this is your n, so don't need to take this one. Find the probability that he or she has at least 13 years in F education. So the question is normal distribution. This is the normal distribution with mean equal to 14 and the standard deviation is equal to 2.75. Now we have 13 years, 13 years. So it asked me to find the percentage or the probability that a person that has at least 13, so it means 13 and more. So that's the required area is this one, 13 years or more. At least 13 years means the probability when x is greater or equal to 13. So what should I find? I find this one. I have first to convert to z, and I have to find the z that's corresponding to this one. So z is equal to 13 minus 14, which is z is equal to x minus mean over sigma. So 13 minus 14 about divided by 2.75, which is equal minus 1 over 2.75, and it's equal to 1 divided by 2.75. 1 divided by 2.75, so it's equal to 0.36 minus 0.366 or 0.37. So what should I do? I will say the probability when x is greater than 13 is equal to probability when z is greater than minus 0.37, and this will be equal to I mean this is here the 13, here's the 3.75, so minus 0.37. I want this area, so I can say this will be equal to the whole area under the normal curve, which is equal to 1 minus this part, and this part is equal to here's the minus 0.37. Why I'm doing this? Because I don't have I have to use the curve. So this area is equal to the whole area minus this area. The whole area is 1 minus this area. It's from minus infinity to minus 0.37. So I can find minus 0.37 from the graph. Yeah, here's the 0.37. Here's 0.3. Yeah, 0.3, then here's the 0.3, then sorry, 0.37, where's 7, so the cross section, here's the cross section, 0.37 is, the area is for 0.30 is 0.3557. 0.3557, so 0.3557, 0.3557, so 1 minus 0.3557 is equal to 1 minus 0.3557 is equal to 64.44, so the area is equal to 0.6444. so this means what this is mean there is a 64.44% probability that the engineer had more than 13 years experience, or what you call it. Now this is the theory part. When I want to enter these data and use the Minitab and be careful, this is the most important thing. For that I will use I will go to the Minitab. Remember that we have these mu is 14 and sigma is 2.75, so I will go here, I will go to the graph and I will go to the probability distribution plot, and I will use view probability, and I will use, this is the mean. I have the mean of this question was 14, and remember that we have 14 and we have we say that we have 14, we have 2.75, 2.75 is the mean. Then after that I will go to the shaded area, and I am looking for an x, which is for this one, and remember that I'm going to find the area after 13, so it means that I have to find the right tail, area to the right. So what will be the area to the right when the x value is 13? And you can find here's the 0.6419, the same area. So this will be the answer. So 64.19 is the area, and also you have to add this one to your data by clicking, and you can do, by the way, more select, you can add labels and graphs and everything that you need. Okay, then yeah, everything that you need. Just go back and you say that select item. I wanna add guidelines, grid lines. Here's the grid line: x major, x minor, y major, y minors, and okay. Then there is this is the density and this is the x. And just you say that save. It's okay. Save. Please save it in the same project, and I will be save it here. Now the other part of the question is say that if a sample of 58 engineers is randomly selected, what will be the probability that the sample average time of the formal education spent by these employees is 13.5 and 14.45? So we know that if I want to solve this one normally within hand calculation, I will say the question is, because of the mean is 14 and the sigma is 2.25 and the samples that I have here is 58, and remember this n is your code. Now what is the required? The required is to find the average of the students of the engineering sample that have between 13.5 till 14.5, and remember that the mean is 14 and the standard deviation is 2.75. so the area is required here. So what should I do? I have to find the z. How to find the z? Corresponding z to 13.5 and 14.5. Because we have the z, in this case we have to find z is equal to x minus mean over sigma divided by the square root of the value of n. Why this happened? Because we don't have any idea about those 58, so the sample is here. So the z1 when will be x1. The z2 one will have z1 is equal to 13.5 minus 14 divided by standard deviation, which is 2.75 divided by square root of 58. Then the z2 is equal to 14.5 minus 14 divided by 2.75, 58. Then it will be 0.5 divided by 2.75, 0.5 times square root of 58. 58 square root of the 58 is 27 times 14 minus 40.5, and then divided by 2.75, then it will be equal to 1.38, I think 3.85, yeah, it means 3.8 is okay. And here's okay the same, but in minus, so there will be 0.5 or minus 1.38. So the question is, when I'm going to convert it to z, this is the z, which is minus 1.38 to positive 1.38, and here's this area is the required area. And how to find this? I will say it will be equal to the area from 1.38, here's all the area, minus the area which is for the left, which is equal to this one, minus 1.38. So this is what we have. So I have to use the both tables that I have to the right and to the left, and 1.38. So what will be the 1.38? Here's the 1.38. This is the 1.38. Here's the 1.38. So 1.3. 1.3. This is 1.3. And what will be the 8? Here's the 8. So it's 0.9162. 0.9162. 0.91. 62. 91. This is 0.91. 62 minus the area which is to the left of minus 1.38. So 1.38 1.38, but now in minus. So what will be the minus? 1.30. This is 1.30. And what will be the 8? Here's the 8. So what will be the 1.38 in negative? It will be 0.0838. 0.0838. 0.08. 0.0838. 0.0838. So what will be the result? It will be 0.91. It will be 0.91, 0.991, 0.91, 0.91, 62 minus 0.0838, and then will be a 0.83. I think 0.8324. This is the theory part, but what about the using the Minitab? Minitab, you need just to change when you are going to enter these data. So instead of using 14, the mean that we have here is 2.75. Use the other standard deviation. The other standard deviation, it will be this is for Minitab. Use mean equal to 14. The mean, the sigma is equal to that sigma, 2.75 divided by square root of 58, which is equal to 2.75 divided by 58 power 0.5 or square root of 1. So the answer is 0.362, 0.361, 0.361. I think we have this one, and we have x1 is equal to, we say 13.5, and x2 equal to 14.5. so these data will be used in the Minitab, and yeah, so we have to go to the Minitab again, magnifier. We have to go to the graph, and from the graph I have to go to the probability, and I have to use this one, and the 14 is existed, so by the mean of the it's 0.361. Then after that I have to go to the shaded area and to use double X, which is between 13.5 to 14.5. then I have find the, yeah, that's 0.8314, the result that I get from this one, which is the same data. Okay, and then you have to save this data, save it in your desktop or in the file, the same folder. Here's the same folder. So you have to name it in a different way. Let me say this is called question 3, for example, for question 3, and then here's the question 3. Save it. Okay. And finally save all the project, and in this way I illustrate all the required tools that you have, and you have to do all the rest of the assignment and using the Minitabs in the same procedures. And if you have any question, please ask and I will answer. Thank you very much, and hope you doing very well, and hope to see you again in the campus. Thank you very much, and good night. Bye bye.